All right, so now that we know where the asymptotes and where the holes and what our domain restrictions are, now we're ready to start looking at actually how do we come up with a graph of these. They don't need to be perfect. We just need to get enough of an idea of what is happening, similar with the polynomials, okay? Now, just like with polynomials, I think this strategy here is a little overambitious. We don't need to necessarily do all of these things. As I mentioned before, symmetry, to me, that's bonus information. If you catch that there's symmetry, great. But if you don't worry about it. Here's what's really important, and this one has a lot more must-dos than the polynomials did. Just like with polynomials, we're going to find X-intercepts and Y-intercept. So we're going to start with the with the Y-intercept. That is, remember, where we do f of 0. Then we're going to find the X-intercepts. And the X-intercepts, think about if you have a fraction, okay, a over b. If this is equal to 0, it's going to be the top that has to equal 0 because we can't divide by 0. So when you want the X-intercepts, you set the top of the equation equal to 0. That's how you find your X-intercepts, okay? Vertical asymptotes come from where the denominator equals 0. So that's where the bottom of your fraction equals 0. That's what we talked about yesterday. Remember, you have to simplify to find your asymptotes. Definitely need to know where those are. You need to know if there's horizontal asymptotes. And then, just like before, you're going to pick some key points. Make sure you pick a point between and beyond each X-intercept and vertical asymptote, and we'll see what that looks like here in a second. Okay, so let's look at just a couple of graphs here. So if we want to graph this rational function, let's start with our X and Y intercepts. So Y-intercept. My pen's dead. Here we go. The Y-intercept is going to be f of 0. So we're going to plug in 0 for x. So that's going to be 3 times 0 minus 3 over 0 minus 2. Well, these are both zeros. So we have negative 3 over negative 2. That means 3 halves, which is 1.5. That's easier to know where to put on the graph. So 1.5 is our Y-intercept. Great. X-intercept. The X-intercept, remember, the bottom of the fraction is 0. That's bad. That's where we get asymptotes and holes and all kinds of other things. So the X-intercepts is just going to be where the top of the fraction is equal to 0. And so that comes out here to be where x is equal to 1. That's our X-intercept. Okay, now we need to know where do we have any vertical asymptotes. Well, we need to check to see if this simplifies any, and we can factor the top, but it doesn't give us anything that cancels out. So remember, for vertical asymptotes, we look at the bottom of the function, and so there's going to be a vertical asymptote at x equals 2. Now we need to look at horizontal asymptotes. Remember, all we care about with horizontal asymptotes is the two first terms. These are equal in power, so the powers cancel each other out, and we're just left with 3 over 1, which is just 3. And since this is a horizontal asymptote, the equation is y equals 3. Okay, that's really all the information that we need so far to be able to pause, kind of like we did before, and we're going to put all of this stuff on the graph to begin with. So I have a Y-intercept at 1.5, and I have an X-intercept at 1. I have a vertical asymptote at x equals 2. That means I have a vertical line that goes through 2 like this. Asymptotes must be a dashed line. That's the only thing that is acceptable, is a dashed line like that. A horizontal asymptote, that's going to be flat. That's going to go through y equals 3. So it'll be something kind of like this. Dash, 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 dash. Okay. And so now we have an idea of what the important pieces of our graph are. This is important because your graphing calculator does not graph the asymptotes. It does not graph the holes. We have to find those out ourselves. But now what we can do is go to your graphing calculator or go to Desmos. What kind of mode am I in here? Hold on. Doing calculus stuff on here. All right. And we're going to put in that function. Be careful when you type these in. If you have one of the newer ones, then it'll type it nicely for you. But if you have one of the older ones like me, you have to type in 3x minus 3 in parentheses divided by x minus 2 in parentheses. So go ahead and put that in and let's see what the graph looks like. Divided by x minus 2, graph. All right, hold on, mine is zoomed in weird. Remember, if you get to a weird zoom, go zoom 6, and that puts you back to standard. Okay, so what you see on your calculator screen should be a graph that looks kind of like this. So you can see on your screen, it doesn't tell us where these asymptotes are. But what we can see is that our graph is going to go through these points here. Whoops, I crossed the asymptote, but it's hard to draw on the iPad. It just gets real close to it. Something like that, but what we don't know is exactly where to put it in that top right corner. So this is where we go to our table. I would probably plug in maybe 3 and 4. So that'll give me 2 points up here somewhere. So let's go to our table and let's put in 3 and let's put in 4. So let's write this down. I'm plugging in 3 and 4. For 3, I get 6, and for 4, I get 4.5. Okay, 3, 6, 4, 4.5. That's good. Whoop, I'm throwing things over here. That gives us a little bit better of an idea of where that needs to go. And that's it. There's our graph. Most of the time, these are a little bit easier to sketch than polynomials because you just kind of follow the asymptotes. You want to get enough of those key points on there so that you have a decent idea, but these are far from going to be perfect just because we are not computers. Okay, let's look at number 11. I would like for you to pause the video and go ahead and go through those first few steps. X-intercepts, Y-intercepts, vertical asymptotes, horizontal asymptotes. And then let's pause to check that before you start graphing. So I'll come back with that information in 3 seconds. All right, when I plug in 0, I get 0 over -9. Remember, 0 on the top is fine. 0 divided by anything is going to be 0. So that's our Y-intercept. When I set the top equal to 0, we also get x equals 0 as our X-intercept. To find our vertical asymptotes, we need to factor the denominator, and nothing cancels out, so both of those are going to give us vertical asymptotes. And then the horizontal asymptote, once again, we're going to compare their strength. So I'm looking at these two. They're equal in strength, so they undo each other, and we're just left with the 2 and the 1. So 2 over 1 is 2. Let's put this on the graph then. Our Y-intercept is 0. Our X-intercept is also 0. Got that. We have 2 vertical asymptotes here. So we're at -3. And also at +3. Okay. And then we also have a horizontal asymptote through 2. So it looks like that. Okay. So I have no idea what this graph is going to look like based on this. So now we're going to go ahead and put that in our calculator. So I'm going to wait for a second to give you time to type that in your calculator and see what the graph looks like. I'm going to do the same. All right. So what you should see is kind of like 2 L-shaped branches in that top left square and the top right square, and then kind of a U shape in the bottom square there. So we just need to get some points to have an idea of where this is going to go. The middle one, we can kind of tell. It's just a U shape that follows the asymptotes like this. That's fine. We need a little bit to be able to tell where to put those other ones. So just kind of like the other one, I'm going to maybe put in -4 and -5, and then +4 and +5, so I can see what's happening there. So -5, -4, +4, +5. So let's go to our table. -5, enter, -4, enter, 4, enter, 5, enter. So I get, these numbers aren't great, but it'll give us enough of an idea. 3.1, 4.6, and then same thing, 4.6 and 3.1. So this is going to be a real rough estimate, but that's okay. So at -5, 3.1, that might be something kind of like right here. -4, 4.6, that's a little more than 4.5, so maybe something kind of like here. And then we just follow the asymptotes. Same thing on this side. And this actually has y-axis symmetry. If you caught that at the beginning, you can see why that would help us out, but that's okay that we didn't. And so that's what our graph looks like. So these graphs do really weird things. So you always got to make sure that you're using your graphing calculator as a tool, but this is where the tool fails us a little bit because like I said, it's not going to show you where there's asymptotes. It's not going to show you where there's holes. So we got to be careful there. Now, one thing that we did not talk about yesterday is there's actually a third type of asymptote. Oh, number 12. I'm going to leave number 12 for you to try on your own and look up in the PDF, okay? So go through all of those points, then download the PDF and check your work and make sure that you have the right answer copied down in your notes because you never know when that question might pop up on a notes quiz when you come back. But this third type of asymptote is called a slant asymptote. And a slant asymptote only occurs in a very specific situation, okay? So instead of being perfectly horizontal or perfectly vertical, it's slanted. So the graph of a rational function has a slant asymptote only when the degree of the numerator is exactly 1 more than the degree of the denominator. So x cubed over x squared, that will have a slant. X cubed over x will not because those are too far apart. The degrees just have to be 1 apart. You cannot have both a slant asymptote and a horizontal asymptote. So you will only have one or the other. If you get a horizontal asymptote, then you're done because it can't also have a slant. But if you get no horizontal asymptote, then you want to check to see if it's a candidate for a slant asymptote. So this is where this ties back in with our polynomials because to find the slant asymptote, we have to do the division of that rational function, okay? And so here with this f of x, they divided that out and they got x plus 1 plus the remainder. We don't care about the remainder. It's the first part that tells us our equation, and it should be something in the form of y equals mx plus b. So for this last example, we want to find a slant asymptote and then do all the rest of the pieces so we can graph it. I'm going to go through this pretty quickly because this video is getting a little bit long. But the process is the same. The only thing new here is the slant asymptote. So let's just start at the beginning like we know how. So f of 0, that's our y-intercept. That's going to be 0 plus 0 plus 7 on the top over 0 minus 1. So that's -1. So we get -7 for our y-intercept. Our x-intercept is going to be where 2x squared minus 5x plus 7 equals 0. I think that's factorable. Let's see, 7 and 1. Yep, that'll do it. Minus, nope, maybe not. Because that's got to be a plus. And they can't both be negative. Nope, this is actually not factorable. Nothing's going to multiply to positive 14, and add to -5. So unfortunately for this one, we'd have to use the quadratic formula to find our x-intercepts. I'm going to go ahead and do that for us real fast. Okay, right away, once I get into this, I notice that I'm going to get an imaginary number here. What does that tell me? That this graph has no x-intercepts. That's why we get imaginary solutions, is when it doesn't cross the x-axis. So we can stop doing our quadratic formula right there because we don't care what the imaginary solutions are. We're just trying to find x-intercepts. Okay, vertical asymptotes. Since that's not factorable, we can see it's already simplified. So the denominator, x equals 1, is going to be our vertical asymptote. Now, when we look for horizontal asymptotes, again, we compare first and first. The top is more powerful, which means no horizontal asymptote because it's going to go to infinity. So since there is no horizontal asymptote, that's how we know to look for a slant. And so we check the degrees. The top one is a squared. The second one is a first power. Those are exactly 1 apart. So that's how I know that this could be a slant asymptote. So what we need to do to figure this out is we need to go ahead and do 2x squared minus 5x plus 7 divided by, because that's what the fraction bar means, x minus 1. Lucky for us, this is in the form of x minus c, which means, thank goodness, we can use synthetic division. So let's set this up. 2, -5, positive 7. Bring down the 2, multiply, add, We do not care about the remainder. All we care about is this right here. So the slant asymptote is y equals 2x minus 3. Okay, so how do we plot all of this on the graph? We have our y-intercept at -7. I think that's right here. We have a vertical asymptote at x equals 1, so that's going to be here. Okay, and then our slant asymptote, that's y equals mx plus b. So it's going to start at -3, that's our y-intercept, and then it has a slope of up 1 over 2, up 1 over 2, up 1 over 2. And so our slant asymptote looks something like this. And with the slant asymptotes, there is not much that we can do to get a really clear picture. So I might plug in just one value, or I might just look at the graph to see like how deep the graph cuts into these sort of sides of the X there. But the graph, when we look at it, is going to come out to look kind of like this. You have 2 branches that follow through right there. So that's how you would handle a slant asymptote. Not really any different. Same process all the way through. All right, guys, I'll see you later.